everyone. Today we'll solve a problem that came in GATE 2021 EC, and this is a problem on the topic of digital signal processing. So the problem is fairly easy, but the solutions that I found for this problem were fairly complex. So I wish to tell you how I thought about the problem. So it is given that there are two 16-point sequences, xn and yn, xn and hn, and the linear combination is denoted by yn. Whereas their 16-point DFTs are taken, multiplied, and then the IDFT is taken, and it gives us Zn. So it is implied that Zn is the circular convolution because that's what the IDFT gives us. It is the circular convolution of Xn and Hn. Okay, this is Zn. Now, since we know the circular convolution, we wish to find out at what values of k are the circular convolution and the linear convolution equal to one another. So the basic thing that is required to solve the problem is to know that circular convolution is n periodic linear convolution, and the n is what is the DFT point of the process. So it is 16 over here. So we have it as 16 periodic linear convolution, and the length of the linear convolution is 16 plus 16 minus 1, which is L plus n minus 1, which comes out to be 31. So as you can see that we have 31 length of yn as the linear convolution. So let's say it goes from index 0 till index number 30. And we have it repeated at 16 intervals of 16. I mean, the 16 periodic yn is Zn. Okay, so if we repeat yn with a period of 16, we obtain Zn because that is how the circular convolution is obtained with the help of periodicity of which is periodic linear convolution. So circular convolution is basically n periodic linear convolution in our case. So as you can see that let's say the linear convolution goes from 0 till 30. We have the next repetition which comes at a period of 16. So it will start over here because it has to have been shifted by 16 units. So it starts over here and again goes till 30. And the next starts over here and again goes till 30. Okay, it starts at 16 and goes till 30. And the thing is, this also protrudes in this. So as you can see, it is easy to keep a track like this. The difference remains 16. So for 40, we'll have 30. So it ends at 14 and it starts at 16. So what you can notice is the index 15 remains common. Here also the index 15 remains common. I mean, there is nothing that is protruding into the 15th index. Things start to protrude at the 16th index or end protruding at the 14th index. So the 15th index is free. So there is no aliasing at the 15th index. It is free from aliasing. Here also, because it is terminated at 14 and it begins at 16. So there is no aliasing while the linear convolutions are repeated with a period of 16. So if you consider yn or zn, they are the same for the 15th index because each one of these is yn and yn repeated with interval of 16 is zn. So at the 15th index, they are the same because there is no protrusion from the left side or from the right side. So the answer to the problem is k equals 15, and it is fairly easy to solve once you know the fact that circular convolution is n periodic linear convolution. That was it for the video. Thank you for watching.